Okay, Algebra 2, this is day 7 notes. All right, we're still in chapter 2, talking about inverses. All right, you can read through this, some reading material. Inverses, they basically undo each other. You can check out example 1, got f of x, g of x, a little review here, trying to get you to see what's going on. They want you to find f of 5 and g of 11. I'll let you guys try that. All right, once you see those answers, it'll make a little more sense. You can try all these, see what you get, make you think a little bit. You can try letter D, it says without even doing the work, what is the answer? F of g of pi. Once you see what's going on there, it'll make a little more sense. I'm gonna jump right down to it though. What are inverses? Inverses are basically functions that undo each other. All right, functions that undo each other. You've probably heard that addition is the opposite of subtraction, right? They're inverse operations, they undo each other. Same idea, except now we're actually talking about functions. F of x, g of x. They throw some letters in there just to make it a little more interesting, I guess. This little mapping diagram, I don't know if it helps or not. Say you have some domain of f, right? F function, g is another function. They're using a's, so some element a is in the domain of f. You plug it into your function, you get out some b, right? Your output, but which isn't part of your range. That b, though, if you plug that into the domain of g, since they're inverses, all right, run it through G, you'll just like run the loop, all right? It goes back and forth, they undo each other, is all that means. All right, so I don't know if you want to write this down, this might help. So if f and g are inverses, all right, you notice how these coordinates have been flipped. So if they're inverses, f of x, that could be the point AB, all right? And then g of x, that would be the point BA. All right, essentially the order changes. Same coordinates, different order. All right, they are inverses of each other. Leads you to number 2. If the point negative 3, 5 is on the graph of y equals f of x, which you'll find is on the graph of its inverse. Well, your point is negative 3, 5, and if you know that it's on its inverse, you're just going to switch the coordinates around, all right? Because any xy coordinate becomes yx coordinate if they're inverses. So just flip it. This is 5, negative 3. All right, choice 3. All right, a little bit more on the next page. Short notes today, not a whole lot. All right, inverse functions have their own special notation. If they are inverses, all right, so if you have a function and its function is an inverse, you can use the notation f to the negative 1 of x. All right, it does not mean raise it to the negative 1 power. It's just notation, all right? Don't get caught up in all these letters and symbols. That just means it's the inverse of f. Let's chunk out number 3. It says the linear function f of x equals 2/3 x minus 2 is graphed. Answer some questions, all right? On the same set of axes, graph the inverse. We have this line. What I would do is I would just get some points off this line, all right? XY table, maybe. Just look at the picture. That's 0, negative 2. All right, keep going, 3, 0. What's this one, 6, 2. You can do a couple more if you wanted to. Looks like negative 3, negative 4. There might be one more. Let's say negative 6, negative 6. So those are on the line. All right, let's say this is like f of x, I guess. I should label it, this is f of x. If I want to do the inverse, f inverse of x, it's going to be a function, so I can label it this. What are my new coordinates? Squeeze them in here. Well, 0, negative 2 is now negative 2, 0. All right, 3, 0 is now 0, 3. I'm just switching the order. 2, 6, negative 4, negative 3, and negative 6, negative 6. So you can plot those real quick. Two 6s up here. All right, close enough. Hopefully your picture looks better than mine. I missed one. It's all right. It's in there somewhere. So there is the inverse function. It is the label f to the negative 1 of x. All right, that is a function, pass the vertical line test, so you can label it f inverse. A couple questions with it. Find f inverse of 2. All right, same idea, except we're going to find the height at 2 of the inverse. So at 2 on the x-axis, the height is 6. So f inverse of 2 is 6. All right, let you guys try another one. What's the height of the inverse at 4? Call it -4. Check that out. What's the y-intercept of the inverse? It's right there in the graph. I got 3. Well, number 4, moving on. Number 4, they give you a table, all right, and the graph. Graph the inverse, all right, same thing we just did. I'll let you guys do that one. Finish number 4, all right, they give you the table, flip the coordinates, graph the inverse, see what it looks like. What do you notice about this inverse? Make you think for maybe a second. That's about it. The last thing is actually kind of important for your homework. Existence of inverse functions. You can read through this. A function will have an inverse that is also a function if and only if it's 1-to-1. So if the original one passes the horizontal line test, then its inverse is a function. As weird as that may sound, read it through a couple times. All right, if you want to jot it down a little bit simpler terms about if f is 1-to-1. All right, maybe I have to remember what 1-to-1 is. Then, squeeze it in here. The inverse is also a function. All right, day 7 notes. Homework's on the next page. Give it a shot, front and back.